Dear second prep, Assalamu alaikum wa rahmatullahi wa barakatuh. It's Mr. Ahmed Mahmoud with you today to introduce a new mathematics lesson. Today, inshallah, we have geometry. It's unit 4, lesson 2. The lesson is called the isosceles triangle. In this lesson, inshallah, we are going to classify the triangle according to its sides, and we are going to learn the relation between the isosceles angle and its angles, and we are going to learn specific the isosceles triangle and also the equilateral triangle. Okay, and we are going to solve many problems about this concept. Let's start the lesson. First, we need to remember the types of triangle according to its sides. First, we have this triangle which is called the scalene triangle, or the triangle in which all its sides are different. The second kind with us is called the isosceles triangle. The isosceles triangle means that the sides which included two equal sides. Okay. The third type with us is called the equilateral triangle, or the triangle in which all its sides are equal in length. Now we have scalene triangle, isosceles triangle, and the equilateral triangle. All sides are different, two equal sides and three equal sides. Now I'm going to speak about the isosceles triangle specific. This is the shape of the isosceles triangle. The isosceles triangle included three sides. Two sides of them are equal and the third is different. The different side is called the base, and the two equal sides called the legs. And we need to remember the names of the sides because he asked us about their names. Okay, now we are going to name the angles of this triangle. The two angles around the base called base angles. Here we have this angle is called the base angle, and this one is called base angle. And the third angle, or the angle included between the two legs, it called vertex angle. Then we have two base angles and a vertex angle. Okay. Now we have a relation between the angles like this. The base angles of the isosceles triangle are congruent, and all of us remember the word congruent means equal in measure. Okay, for example, if this angle equals 70, then this angle must be 70 because they are equal in measure. Okay, to find the third angle we are going to do the following. We are going to make 180 minus 70 plus 70 equals 40 degrees. Again, if we have isosceles triangle, if we have two equal sides, then we have two equal angles. The two angles opposite to the two equal sides are equal in measure, or the base angles are equal in measure. And to find the measure of the third angle, we are going to make 180 minus the two other angles, give me the vertex angle. Now I'm going to speak about the equilateral triangle like this. This is the equilateral triangle, or the triangle in which included three equal sides. Okay, this triangle, okay, called equilateral triangle or equiangular triangle. Again, if the triangle equilateral, it is equiangular. What's the meaning of equiangular? Equiangular means its angles are congruent or equal in measure, where each of them equals 60 degrees, as we see here. Here we have three equal sides and three equal angles, each of them equals 60 degrees, and this is constant number of the angle of this angle. Okay, now we have a relation. If we have two equal sides, then we have two equal angles, and if we have three equal sides, then we have three equal angles. Let's solve problems about the isosceles and the equilateral triangle. Number one, Here we have, in each of the following, find the value of the symbol used for the measure of the angle. Number one, here we have the double dash and double dash. That means those angles are, those two sides are equal, or those two sides are the legs of the triangle. Then angle x and 50 are the base angle, then they are equal in measure, then x equal 50 degrees. The next one, here we have the legs here, and this is the base angles. Now this angle equal also 62 degrees. Okay, then to find x here equal 180 minus open brackets 62 plus 62, then x equal x here equal 36 degrees. Okay, the next one, excuse me, it's 56 degrees. The next one, here we have the two legs here and here, this one and this one. Then those two angles are equal in measure. Okay, then y. Okay, this one is y and the other one is also y. To find y here, we are going to do the next. I'm going to make 180 minus 54 over 2. Again, 180 minus 54 over 2. It's equal 63 degrees. The next one, here we have the base, the legs are those two sides, then this one 65 and this one also 65 degrees, then L equals 65 degrees. To find Z, we are going to do 180 minus open bracket 65 plus 65, it's equal 50 degrees, then Z equal 50 degrees. In this one, here we have ABC is a triangle in which AC and BC are equal. Then AC and BC are the two legs. Okay, this angle equal 63. To find y, because we have here one straight angle, here we have this is a straight angle, then it will be 180 minus 63 equal 127. Okay, now x equal what? 180 minus open brackets 63 plus 63, which is equal 54 degrees. Then x equals 54 degrees and y equals 180 minus 63 equals 127 degrees. This is 127 degrees. Let's solve the next example. In this example, AB equal AC equal CD, as we see here. Measure of angle B equal 70. Find with proof measure of angle BAD. Okay, first angle C equal 70 degrees. Because this is the isosceles triangle. Measure of angle BAC equal 180 minus 70 plus 70 equals 40. And I need measure of angle BAD. To find this angle, First, I need to find this angle. 180 minus 70 equals 110. And this angle 180 minus 110 over 2 equals 35 degrees. Then angle BAD, this angle equals 40 plus 35 equal 75 degrees. Okay, now I'm going to write the proof. Since first in triangle ABC, since AB equal AC, therefore measure of angle ACB, which is C, equal to measure of angle B equals 70 degrees. Okay, since the sum of triangle equals 180, therefore measure of angle BAC equals 180 minus open brackets 70 plus 70 equals 40 degrees. Since BD is straight, segment, therefore measure of angle ACD equal 180 minus 70 equals 110 degrees. And since AC equal CD, therefore measure of angle CAD equal to measure of angle CAD equal to measure of angle CDE equal 180 minus 110 over 2 okay, it's equal again 180 minus 110 over 2 because it's not clear here equal 35 degrees. Okay, therefore measure of angle BAD equal 40 plus 35 equals 75 degrees. The next example. ABC triangle isosceles here, and ADC is an equilateral triangle. Okay, measure of angle ABC equal 40. find the measure of angle BAD. Okay, first we have here equilateral triangle, then the measure of each angle equal 60 degrees. In the other triangle, we have 180 minus 40 equals 140 divided by two equal angles. It will be 70 here and 70 here. Then angle BAD equals 70 plus 60 equals 110. In triangle ADC, since AD equal to DC equal to AC, or you can say that the triangle is an equilateral triangle. Okay, therefore each angle equal 60 degrees. In triangle ABC, since AB equal to BC, therefore measure of angle BAC equal to measure of angle BCA. And since the sum of triangle equal 180, therefore measure of angle BAC equals 180 minus 40 over 2 equals 70 degrees. Finally, therefore, measure of angle BAD equals 70 plus 60 equals 130 degrees. The next example. Here we have example 4. Now we have ABCD is an quadrilateral. Measure of angle A equals 120. AD parallel to BC as we see here. Measure of angle BDC equals 65 degrees. Find the first measure of angle ADB. Find the measure of angle ADB, this one. And measure of angle C. Okay. The first triangle ABC is an isosceles triangle. Then to find the base angles, it's 180 minus 120 divided by 2 equals 30 degrees. Now this angle 30 and this angle also equal 30. Here we have alternate angles here. Okay, then angle D reflected down here, it will be also 30 degrees because the Z shape as we see. Okay, finally angle C, it's equal 180 minus 65 plus 30, it's equal 85 degrees. Okay, first, since of course in triangle ABD, since AD equal to AB, therefore measure of angle ADB equal measure of angle ABD equal 180 minus 120 over 2 equal 30 degrees. Since AD parallel to BC, you can write DB is a transversal or not. Therefore, measure of angle ADB equal to measure of angle ABD equal 30 degrees, and this is called alternate angles. Okay, and then in triangle DBC, since the sum of triangle equal 180 degrees, therefore measure of angle C equal 180 minus open brackets 65 plus 30 equals 85 degrees. The next example, example 5 here. In the opposite figure, okay, as we see, this angle equal 130 and xz equal yz and xy parallel to LM. Okay, find the measure of angle MLY. Find the angle L. Okay, first I'm going to find angle next to 130, because we have a straight angle here. It's equal 180 minus 130 equal 50 degrees. And then angle X and Y are equal because this is an isosceles triangle. Then this angle equal 180 minus 50 over 2 equal 65 degrees each. Okay, now we have alternate angles. Okay, as you see here, this is alternate angles. Then angle Y equal to angle L equal 65 degrees. Okay, now I'm going to write the proof. Since Z belong to LY, therefore measure of angle XZY equals 180 minus 130 equals 50 degrees. In triangle XYZ, since XZ equal to YZ, therefore measure of angle X equal to measure of angle Y equals 180 minus 50 over 2 equal 65 degrees. And then since XY parallel to LM, therefore measure of angle Y equal to measure of angle L equal 65 degrees. Don't forget to write the name of the relation, which is alternate angles. Alternate angles. The next example. Here we have A belongs to BD, as we see, and AB equal to AC. AE parallel to BC. Prove that AE bisects angle DAC. DAC. Okay. Now we have here isosceles triangle. In this triangle we have angle C equal to angle B because they are the base angles. Okay, don't forget we have AE parallel to BC. Then we have here Z shape. Then angle A equal to angle C. Okay, and we have also Z shape, angle B equal to angle A. Sorry, we have F shape like this. As you see here, angle B equal to angle A. Its corresponding angles. Okay, since angle DAE equal to angle EAC, then AE bisects angle DAC. Okay, the proof. Since AB equal to AC, therefore measure of angle C equal to measure of angle B. And since AE parallel to BC, therefore measure of angle C equal to measure of angle EAC. Okay, and this is alternate angles. Therefore measure of angle B equal to measure of angle EAD. And this is corresponding angles. Therefore measure of angle EAD equal to measure of angle EAC. Therefore AE bisects angle DAC. The next example. Complete the following. The base angles of the isosceles triangle are, you can write congruent or you can write equal in measure. I will write congruent. The measure of each angle of the equilateral angle, of course, it's equal 60 degrees. DEF. DE equal to DF. Okay. DE equal to DF. Okay, then measure of angle E equal to measure of angle F. Of course, you need to draw it in the exam, okay, to be clear. The next number 4, ABC triangle, AB equal AC, A, B, C, AB equals AC, and angle A equals 80. To find the angle, then angle B equal to angle C equals 180 minus 80 over 2 equals 50 degrees. And this is the end of this lesson. I hope it was helpful for you. See you in the next video inshallah. Assalamu alaikum wa rahmatullahi wa barakatuh. Mr. Ahmed Mahmoud was